Hello there, and welcome to another edition of Starry Skies, the monthly magazine where we talk about what you can see in the night sky this coming month. And I'm Mark Hardacre.
And I'm Steve Tonkin.
And welcome back, Steve. We missed you last month.
Thank you. Yes, I was poorly. Poor little me.
Yes, he was properly poorly as well. I'm looking at he's on the couch next to me here. A mere shadow of man he formerly was. Lost a lot of weight and feeling a lot better, I hope.
Yeah, indeed.
Yeah, so we're going to talk about July now, aren't we, Steve, for the month?
We are.
And, it looks like summer's arrived. It's a bit sticky in this recording studio, isn't it?
Yeah. Well, let's just hope it stays like that so people get at least a part of a decent summer.
Yeah, let's hope so. Anyway, in the night sky, it definitely still is summer, of course. Because on the 1st of July, sunset is still at 9:24 and sunrise at 5:58. So we don't get much of a night, do we?
No, but there are things we can look at in the night sky, and we will cover some of those for you.
Indeed we will. So by the end of the month, you're not too bad. It's 8:54 p.m. sunset, and sunrise is at 5:33. So days are shortening, sadly to tell, and the nights are darkening. Although in here, in Verwood area, we don't get any astronomical darkness at all until the 17th of July.
That's right.
That's astronomical
17th
twilight.
of July or 17th of August?
Of July, yeah, of July. I checked it this morning just to be sure. 17th of July here in Verwood. That's when we get astronomical darkness, which is proper dark, isn't it? So, what about the planets? They've been a pain this year, haven't they?
Oh, well, they were okay right at the beginning of the year.
Yeah.
But, at the moment, no, nothing really worth seeing unless you get up bright and early in the morning.
That's it. July continues this trend of being a planet-free evening. Both Mercury and Venus are far too close to the Sun to be seen. You might just catch Mercury furthest from the Sun in the mid-month, but it's so difficult to see. And all the remaining planets are only visible in the morning sky. So first up around 1 a.m. is Saturn. Pretty inconspicuous, low in Pisces in the southeast. It's not as bright as usual as its rings are slowly closing. How does that ring closing thing work, Steve?
Well, if it's tilted with respect to its orbit round the Sun, just as we are. And so depending on where it is in its orbit, you can either be looking at the rings from, where they're sort of pointed compared to us downwards, so you see the full ring system, or when they're pointed upwards, and then in between, it's like they're pointed sideways. And when they're pointed sideways, they edge on, and you can't see them.
Yep.
So imagine a saucer going round you at or a plate, tilted exactly the same way and pushing it around you. There will be places where you can see the top of it, there'll be places where you can see the bottom of it, and there'll be places where you can see it edge on.
Yeah. And that's what we're coming up to. So if you train your telescope, and you'll need telescope, not binoculars, but train your telescope on Saturn, you'll be surprised, really, to see that the rings are almost not there anymore. They're a very, very thin line to the left and right of the planet's globe. And next year, they will disappear completely. Even in a good-sized telescope, the rings will disappear as they go completely edge on as seen from the Earth. And then the year after, 26 and 27, they'll open out back again.
Yeah.
So, that's Saturn. You've got to see that. That's 1 o'clock in the morning you'll see that rising.
That was actually one of the things which baffled Galileo at first, because when he saw Saturn through his very poor telescope, much poorer than anything you'd buy nowadays, when he saw the rings, he didn't realize it was a ring system. He thought it was a little moon or something either side of it.
Right.
And then gradually they shrunk.
Right.
And to the ancient Greeks, which of course Galileo knew about, Saturn was Kronos. And in Greek mythology, Kronos ate his children. And Galileo actually wrote down, has Kronos eaten his children?
Yeah, and of course it took much better optical equipment a couple of decades later before it was clear that, I think it was Cassini, wasn't it?
It was Cassini, yeah.
Cassini, a Dutch astronomer, I believe, who was able to see for the first time that there were rings around Saturn and not these satellites. Anyway, so what happens next is 1 o'clock in the morning, up comes Saturn. And then you've got to wait until 2 a.m., 2:30 a.m. to see faint Mars rising in the east. It's very faint.
It is faint,
It's
yes.
going to be absolutely gorgeous this coming winter, but it's still too far away from us. You can easily see it in the constellation of Taurus, but it will be marvellous in autumn. Just forget it for now. And then as twilight starts, you'll be able to see the bright planet Jupiter returning to the morning sky. It rises about 4 a.m., so just before the sun.
Yeah.
So it's not a great time to see it, really.
No, it's not. Give it another month at least.
Yeah.
So when it's rising, again, much greater time before the sun, it'll be fine.
Yeah. And we're going to really have a great autumn parade of stars, aren't we? It's going to be great. We're going to have some great planets in autumn time, and we'll come to that as we do more starry nights. Good.
So, constellation of the month, then.
Right, what about that then? So we've picked this month, one of both our favourites, really, Steve,
Yeah.
isn't it? We both love the constellation of Sagittarius, which is one of the zodiac constellations.
And what does Sagittarius mean?
Well, it's represented in the sky as a centaur, which is a half man, half horse, firing a bow and arrow.
Yeah. Hence Sagittarius arrow.
Right. And the Arius bit? You don't know that, do you?
Well, the Arius is it's the one who shoots the arrow.
Right. So Sagittarius, one of the 12 zodiac constellations. That means the sun and the moon and all the planets pass through Sagittarius as they wander their way around the orbit of the sun. As seen from us, they appear to pass through Sagittarius and all the other zodiac constellations too. It's a shame because Sagittarius is such a brilliant constellation if you are south. I was lucky last month I was on a cruise and went down to Malta, where Sagittarius is higher in the sky than it is here in the UK. What a sight, Steve, huh?
Oh, fantastic. Well, where I grew up in what is now Zimbabwe, Sagittarius would go almost overhead.
Yeah.
And that is, then all the stuff we're going to be talking about now, which is quite tricky to see because it's so low in the sky, is absolutely glorious. So if you get a chance to go further south at any time on your summer holes or something like that, or visiting people in southern hemisphere, then do take it, 'cause it really is worth the effort.
Yeah, take your binoculars with you, of course. So how do we find Sagittarius in the middle of July in our skies here in Dorset, Hampshire, Steve? How do we find
Well,
it?
it'll be pretty much due south
Right.
in late evening. So that's, when the skies, at least in the south, is starting to get dark.
Yeah. So around midnight local time-ish. Yeah.
And everyone seems to think the main stars, the brightest stars of it, form the shape of a teapot with a pointy lid.
And it does. That's the bit that you'll see.
Yeah.
So what I like to do is to drive to the south coast, go down to somewhere where you've got a good view out to sea looking south, or on a hill looking south, and train your binoculars at the horizon and then move them up, and your binoculars will be filled with the stars of the Milky Way.
Yeah.
And all around there is the constellation of Sagittarius. As Steve just said, it's a teapot. An old-fashioned teapot,
Old-fashioned teapot,
with a lid and a spout and a proper handle.
And the Milky Way looks like the steam coming out of the spout.
It does indeed.
Yeah.
We've put a map of Sagittarius on the Forest FM website, also the Fordingbridge Astronomers website and the Wessex Astronomical Society website. So go and have a look at that and actually download it and print it out, because some of the things we're going to talk about shortly, you'll need this map to find some of the objects in the sky. Sagittarius, being close to the centre of our galaxy, is packed with dark sky or deep sky objects that you can see with the naked eye, if you're lucky, and certainly with binoculars.
Oh, yeah. Binoculars, I think, an absolute must. I think the best way to enjoy that region is binoculars, because there are bits of it. They're really dense bits of the Milky Way.
Yeah.
Bits that, if you're inexperienced, you might think, oh, that's a cloud.
Yeah.
Well, it is a cloud, but it's a star cloud. It's not a rain cloud or anything like that. And a binocular view of that, you'll see more stars in the field of view of binoculars in that part of the sky than anywhere else ever. It is really glorious. So just scan along the Milky Way. It's really, really rewarding. And then you'll see little knots of stars.
Yeah.
And the problem is not finding these little groups of stars or anything like that. The problem is identifying the ones you do find. So there's just so many of them.
Yeah, which is why we really say, take that map with you, print it out and take it with you, because it will definitely help you to find, for instance, the globular cluster M22. That's the one we're going to start with. Just have a look at the map and you'll see where it is. It's just above and to the left of the Teapot lid. It's marked with a little yellow circle there. It says M22. See if you can find that with binoculars. It is a magnificent globular cluster. What's a globular cluster? Well, I think it's like
a few 100,000 stars. Is like the core of a galaxy, really.
I like to think of it. I was on the cruise. I was telling people, look for something, or it feels like a snowball full of diamonds.
That's a lovely way of putting it,
isn't it? Yeah, and it really looks like that. Of course, when you see it on in a big telescope, that's what it looks like. In binoculars, it's a small fuzzy patch, but really quite distinctive. You can't miss it. It was the 22nd object found by our French friend, the astronomer Charles Messier from Paris. And as I said, you can't miss it. Point your binoculars at the top of the Teapot lid, and there you'll have it. There's a couple of other clusters. Again, look at the map and skew across to the area that's marked there, M8 or M20. That is just lovely in binoculars, Steve.
Oh, it's glorious. You start seeing these misty patches. They're indistinct, and give yourself time, because the longer you look, the more you will see.
Yeah.
Because your eyes will gradually become more and more dark adapted. It can take up to 40 minutes.
Yeah.
But you will just see more and more and more.
Yeah.
And if you don't get artificial light into your eyes while you're doing this, you'll wonder why you couldn't see all of this stuff right at the beginning.
Yeah. Yeah. But again, most of our constellations of the month have got 2 or 3 objects, don't they? And two or three prominent objects. But we are spoilt for choice here with Sagittarius. I mean, the clusters, again on the map, M23 and M25, you can see them quite a bit above the top of the Teapot there. Lovely little star clusters. They were all formed together from collapsing dust clouds and gas clouds eons ago, but the stars are still clinging together like brother and sisters. Probably dozens or tens of dozens of stars at most in these clusters.
Yeah.
And eventually they will find their way into the rest of the galaxy and disappear. But for now, they're prominent little clusters of stars, easy to see in your binoculars, and very nice. And as Steve said, the whole area is Milky Way. The Milky Way passes right through here. So wherever you're looking, you've got a binocular full of diamonds, haven't you?
Yeah, it is glorious.
Yeah.
And the open clusters that Mark's talking about, one of the ways of recognizing those, except for the very, very old ones, they're usually very, very bright, almost bluey white stars, which is an indication they're very young.
Yeah.
So that enhances the diamond effect of them. It really is lovely.
And if you look at that area M8 or M20 marked in green on the chart, they are gas clouds that are being illuminated by stars nearby. And this, in fact, is where star clusters are being formed. Yeah. These patches of gas, as we see them in the sky now, are collapsing and will, in millions of years to come, form clusters like M25 or M23, right?
Yep, indeed.
And it's like watching a celestial history lesson when you go through these clusters and nebulae.
Oh, it is, because you'll also see the dark patches in the Milky Way, which are not holes in the Milky Way. That's actually foreground gas and dust. So that's where stars have come to the end of their life, and they've effectively exploded in one way or another. Yeah. And they've given out lots of soot, and in case of bigger stars, silicon. So you're talking about soot and sand, carbon and silicon, a lot of it there. And that is actually, it's foreground dust.
Yeah.
That you're seeing in the dark patches. If we look higher in the sky, it looks like a rift right through the middle of the Milky Way.
Yeah. All the way up into Cygnus. We'll talk about Cygnus in a minute. So do enjoy our constellation of the month. Sagittarius is such a lovely place to train your binoculars. As I said, get south, get a clear view to the south, see if you can do that. Dark adapt your eyes, so not straight out of your car and straight with the binoculars. Give yourself at least 10-15 minutes to get your eyes used to the dark, and then peer into the south around midnight, mid-month, and you're in for a real treat down there. It's absolutely delicious.
It is glorious.
Yeah. So, what else can we see overhead during the summer months, all the way through, in fact, to October and November, is the summer triangle, Steve.
Yeah. Which is a triangle of...
No.
Oh, really? It really is.
Really a triangle?
It's not an equilateral triangle, so don't expect an equilateral triangle. It's a triangle of 3 bright stars. The one you'll notice first probably is Vega, which is right next to a little parallelogram of fainter stars.
Yeah.
And that is in the constellation of Lyra. Then you've got Deneb, and then lower to the south, you've got Altair. And those stars form the summer triangle, and you can use them as a sort of jumping-off place to find other things, which is what's glorious about them.
Yeah. The great thing about the summer triangle is because it's high in the sky now in July, as the evenings shorten, or the evenings lengthen, or whatever. Yeah,
evenings lengthen, days shorten.
So the summer triangle stays in very much the same place all the way through until November. It's quite strange, because if you look at 6 o'clock on a November evening, as opposed to midnight on a July evening, the stars are in pretty much the same place. Yeah. So the summer triangle is easy to find through much of the year, late spring all the way through to winter. And as you say, you can't miss bright blue diamond, brilliant white Vega, which is more or less overhead, high in the south. It's only 25 light years away from the Earth.
So what does that mean?
So 25, you're like, do you know what? That's a question that was asked on my cruise as well. In fact, someone said, compared to a normal year, how long is a light year? And I said, let's get that clear. A light year is a measure of distance.
Yes.
Whereas a year, of course, is a measure of time. So the connection is, how far does light travel in 1 year? The answer, of course, 1 light year. But how many thousands or millions of kilometers is that? And it's a massive number, which is why we don't say Vega is 125,000 million, or is it another million? It's just too long. So 25 light years is the distance that light travels in 25 years. And it's an enormous number of miles. Enormous number.
It is. When you think that it'll go 7.5 times around the Earth at the equator in a second.
Yeah. And get to the moon in a second and a half.
Yeah. And the sun in 8 minutes and 19 seconds.
Yep. and even to the outer reaches of our solar system in a few hours, and then light will continue to Alpha Centauri in 4 years, and eventually get to Vega in 25. So Vega's 25 light years away. The other star in the constellation, in the triangle we're talking about, Altair, the one further south.
It's got a little faint star either side of it, like 2 little outriders.
It does, and that's only 16 light years away. So both Vega and Altair are relatively close. But the other star, Deneb means the tail, right? The tail of the swan, isn't it?
Yes, Cygnus the swan.
That's it, Cygnus the swan. So Deneb is 1,400 light years away. So a vast distance, and yet it's nearly as bright as the others. That must mean, of course, it's incredibly bright close up, right?
Indeed. So stars are not all the same brightness. They used to think that the brightest stars were the closest ones and vice versa. We now know that's not the case.
Yeah.
Stars vary so much in colour, which a lot of people don't realise until they actually sit and look at them. They go from bluey white right down to a sort of quite deep orangey red.
Yeah.
And they vary enormously in brightness.
Yeah. So these 3 in the summer triangle, pretty much the same colour, Steve, right?
Yeah.
Pretty much whitish, bluish, whitish.
Yeah, bluish white.
And not quite the same brightness. You've got Vega, definitely the brightest of all of them, but the other 2 are pretty much the same. So it's a clear isosceles triangle in the sky.
Yeah.
Yeah. And I was hoping that Steve would tell us it's an isosceles triangle because he was a math teacher. Is it isosceles? Am I right?
It's almost almost isosceles. Yeah. I mean, okay. If you're not being fussy, it's an isosceles triangle with Vega and Deneb forming the base, so it's upside down, and Altair forming the point that's slightly further away than the others.
Right.
Yeah.
Anyway, that's our review of the summer triangle. As I say, you'll be able to use the summer triangle to find other nearby objects, and again we'll put some more details of that on the website.
Yeah.
Do have a look at the websites and download those charts and print them out, because they will help you to find your way around the stars. We put them up on the Fordingbridge Astronomers website. We meet as a club every third Wednesday of the month in Ringwood. The Wessex Astronomical Society meets on the first Tuesday of the month at the Allendale Centre in Wimborne, and
the Cranbourne Chase Astronomy Club meet in just outside Shaftesbury, and that's on the second Wednesday of the month.
Yeah.
So you've got every week almost there's something local-ish going on.
Yeah. And of course, don't forget, all of these societies will be at various fairs, county fairs, summer fairs during the summer. More notice about that as time goes along. But it's a good time to meet astronomers. It's a good time to see the telescopes that we have in a nice daytime environment. So lots of fun there.
Indeed.
So next month we're going to be talking about August. We're going to be talking about the Perseid meteors, aren't we, Steve?
We are, because that's probably... For most people, it's the best meteor shower, because it takes place when the weather's still quite warm, so people are prepared to go out and look at it. But we'll save that for next month.
We will. So, from Mark Hardacre
and Steve Tonkin,
we wish you all the best, clear skies, and a nice warm July.
And keep looking up.
Keep looking up.